Hi, my name is Eyal and I manage software development at Adesto. Previously, we introduced the EVK board, which uses NXP's i.MX RT1050 MCU and Adesto's EcoXip flash memory. In this part, I'll explain how to develop XIP code for this board. We are talking about application programs which resides on the EcoXip memory and execute in place from EcoXip. The demo which you saw in the first part is an example of such a program. Please note that detailed information about this development process can be found in application note AN106, which can be downloaded from Adesto's website. The first thing we must do is create an EcoXip bootable image for our application program. This will enable the i.MX RT1050 to start executing the application program directly from the EcoXip flash memory shortly after reset. Here's how it works. After reset, the i.MX RT1050 runs a small bootloader. This ROM bootloader reads a flash configuration block which provides information on how to set up the MCU and the external flash memory for optimal in-place code execution. Once the bootloader applies these settings, it jumps to the application which resides on the external flash. Adesto provides a flash configuration block which is optimized for EcoXip. This block comes in the form of a source file and is linked to the top of the bootable image where the ROM bootloader expects to find it. The i.MX RT1050 SDK has plenty of example projects which create flash bootable images. Just make sure you use the EcoXip flash configuration block when you build any of these projects for EVK. Next, we'll take the image we built and program it into the EcoXip flash memory. To do that, we configure the debugger to use an EcoXip flash loader plugin during download. Where exactly this is done depends, of course, on the tool chain we are using. Once Flash Loader is configured, we can go ahead and tell the debugger to download the program we built in the previous step. This will automatically program EcoXip with the image of that program. Now we are ready to run the program. One option is to stay in the debug session and run the application program from the debugger. Or we can run the program standalone. We first must set the dip switches as follows. SW7 will be set to off, off, on, off. This will tell the i.MX RT1050 ROM bootloader to boot from the external flash memory. We also want to set SW5 to off, on, off. This configures a delay between flash reset and the first flash access to make sure execute in place doesn't start before EcoXip is ready. This is a good place to mention that the i.MX RT1050 ROM bootloader will always reset EcoXip when it starts up. This ensures that the MCU and the flash memory never go out of sync. Okay, now let's power up the board and run the application. Hey, it works! And this concludes part 2 of our video series.